Hey everyone, Troll here. Today we are going to talk about another interesting JavaScript interview question, and it is JavaScript engine internals. We'll talk about JavaScript bytecodes, what actually JavaScript JIT compiler, how JavaScript engine internal works, what is JavaScript compiling process, interpretation process, translation process, the parsing, abstract syntax tree, why we need abstract syntax tree, how optimization happens. All these questions we'll try to cover in this tutorial, so stick around. Let's get started. Let's first try to understand what is JavaScript engine. JavaScript engine is a special program that's able to read JavaScript code, parse it, and translate it into machine instructions. Okay, this is a middleman that's able to read our JavaScript code and translate it into machine instructions. So translation is a general purpose understanding. It is possible to have interpretation, compilation, or both work in a hybrid mode, but right now it doesn't matter for us. We have only one general understanding as translation process. So we have JavaScript code, so we have JavaScript engine that's able to translate our code into machine instructions. If you follow ECMAScript engine's standard, you are able to create your own JavaScript engine, but you should follow this document, okay? So all companies who work on JavaScript engine should follow this document. Otherwise, your JavaScript code will work, for example, on Firefox, but will not work on Google Chrome. So to make them compatible, to make JavaScript code to work in all sorts of browsers, you need to follow ECMAScript engine's standard. So you can search for ECMAScript engines and you can find list of ECMAScript engines on internet. So in general, we have a lot of different engines. For example, Google has JIT engine, Firefox has SpiderMonkey, we have Chakra, JavaScript Core, etc. Tons of JavaScript engines. They are following the ECMAScript engine standard to have same functionality to help us to run our JavaScript code in any browser. Okay, so in general, we have JavaScript engine that's able to read our source code and translate it into machine instructions. Now let's try to understand the internals of JavaScript engine. Now it is time to talk about JavaScript engine internals. We learned that the responsibility of JavaScript engine is actually to read, parse, translate your JavaScript code into machine instructions. That's simply a bird's eye view, but let's see how internal things work. I will focus on web-based JavaScript, things like HTML, CSS, JavaScript. In our case, we have simple HTML file. Let's see, where is this one? This is our sample HTML. This is our really simple HTML file. This HTML file may consist from the HTML tag itself, text itself, and styles, JavaScript. In our case, we have reference to JavaScript file. HTML parser, we have special mini application called HTML parser in our browser, and the responsibility of HTML parser is actually to parse our HTML, try to understand it, and in case of it reaches to the script file, it will try to grab this script from the source. We may have multiple sources. For example, we have network here, cache here, they are sources for us. We may have different sources. Right now, it doesn't matter for us. Just think that we have a source of JavaScript somewhere and we are getting this JavaScript. But how we are getting it? Actually, we are not getting it as a file. We are getting it a byte stream, as a byte stream, okay? And it looks like something this. And in our case, we have special sub-element called byte stream decoder that is going to decode our JavaScript bytes and create tokens based on these bytes. So for example, you have something like this, and byte stream decoder will try to understand what is the meaning of this byte stream. For example, it is possible to get let, const, func from this byte stream, and this byte stream decoder will understand that, okay, this is a function, this is a variable, this is an object, etc. Okay. And at the end, we will provide these tokens to our parser. But truth be told, there is no need to dive more like this. Just simply understand that we have simple JavaScript code here. Okay. It is better actually to understand how we are getting this JavaScript code, but in a final stage, we have some sort of JavaScript code, and this JavaScript code will be provided to our JavaScript engine as an argument. And this JavaScript engine may consist from different elements based on JavaScript Engine implementation. Right now, we'll talk about V8 Engine because this is really popular, the fastest engine, and also Node.js uses V8 Engine. So it is better to understand things from the V8 Engine perspective. And the first sub-element, so in general, engines consist from multiple sub-applications, okay? The first sub-application here is going to be parser. The parser is going to accept your JavaScript code, the byte stream as the decoded byte stream as an argument, and generate abstract syntax tree. Let's see how abstract syntax tree looks like. So just navigate to astexplorer.net, and here just type any code you want in JavaScript, and you will get the exact syntax, abstract syntax tree representation of it, like in a tree format or JSON format. It is better actually to track it in tree format. For example, here we have print names. This is our function. So as you can see, we have function declaration. This is a sub-element of abstract syntax tree. What is abstract syntax tree? Abstract syntax tree is a special sort of data structure that's understandable by our interpreter. We'll talk about the interpretation process, but actually this is an internal representation of the JavaScript for JavaScript Engine, okay? And it has a lot of declaration forms, for example, variable declaration, function declaration. In our case, we have names as a variable, so we have variable declaration. We have print names. They are the simple examples provided by AST Explorer, and we have function declaration for print names. So let's say inside we have ID, expression, generator, body itself. The body uses expression tree, etc. So actually, it doesn't matter for us how things happen. Just try to understand that we have abstract syntax tree. This is a data structure, special internal data structure for our JavaScript engine, okay? And also the responsibility of parser is not just convert your JavaScript stream into abstract syntax tree. One of the responsibility of parser is being a lexical analyzer, okay? For example, you typed something wrong in JavaScript and it will not be parsed. You should provide exact JavaScript syntax code to be parsed into abstract syntax tree, okay? We have some sort of validation security level in our parser, and we are getting abstract syntax tree. It consists from multiple declarations, and also it has a lot of additional information, but right now let's just bypass them. And the third step here is we have interpretation. Truth be told, the first JavaScript engines were just interpretation-based JavaScript engines. So in the last years, they started to work on JavaScript engine to add more optimization-based stuff. And right now, JavaScript engines, some of them uses JIT compilation mechanism. We'll talk about JIT compilation mechanism. This is just a helper for our interpreter to run the things faster, to optimize the things, okay? We have interpreter, and this interpreter is called ignition in V8 Engine. The responsibility of interpreter is first read your abstract syntax tree and generate bytecode. What's the interpretation process? Interpretation is a type of translation. So in our case, we have two main types of translation: compiling process, interpretation process. Interpretation is really fast when you are up to running stuff and when you read things line by line and convert it to machine instructions. This is a general way of how interpretation process works. And from the compiler perspective, we are reading all the source code and converting it to machine instructions, okay? In our JavaScript engine, we have ignition. This is our interpreter, and this interpreter will generate a special bytecode. I will show you an example of bytecode for you. In Chrome also, we are able to see this bytecode, and in Node.js, it's really easy for us to see this bytecode. This bytecode is a special representation of your code. This is one abstract layer over machine instructions, and it is really for our interpreter to understand this bytecode. So the interpretation generates this bytecode, and using this bytecode, it is faster for us to provide data to our machine, to our hardware, to understand JavaScript instructions, okay? And we have one additional component here called profiler. The responsibility of profiler is actually to help us to optimize our code. But first, let me show you an example of bytecode. In our example here, we have func.js. As you can see, this is simple calculation process that accepts 2 arguments. I will go to terminal, new terminal, and I will just run this JavaScript code using node. Node, we have special argument, print bytecode, and I will provide another attribute here, print bytecode, and I want just to filter our calculate, because when I run node print code our func.js, it will generate all the stuff related to this file as a bytecode. But I just want to focus on calculate, so I am just providing func.js like this, and this means generate, show me the bytecode that's related to calculate. Okay, let's hit enter, and here we are. This is our bytecode. Okay, this is similar like assembly programming language, but this is abstraction over this assembly. This is a special language for our JIT compiler to compile this stuff. Okay, and we have special element here. This is our profiler. The profiler's responsibility is check if we have some hot code in our application. It means, for example, if you have some function that is repeatable called, it means we are able maybe somehow to optimize it. If there is something to optimize, our profiler will take this information and provide it to our optimizer. This is compiler optimizer. In general, it's called optimizer. And this optimizer will optimize your code directly generating machine instructions. So in case of trying to call this function again, system will not generate bytecode, but instead will directly call our optimized code. And this optimized code is a machine instruction itself, so there is nothing to do with bytecode, and it is just really easy for us to fastest way to provide this data to our hardware. And it means it is really easy for us to provide data in the fastest way to our hardware to understand. And this is our optimization side. It means we are just bypassing this bytecode step. This is the bytecode is also fast, but this is a middleman. This is a middle language, and it would be better somewhere to not to use this bytecode directly talking to machine language. And that's what our compiler, our optimizer is doing here. So far, we talked about JavaScript translation process, and happily we have in our JIT engine 2 sorts of translation, one for interpretation, the other one for compilation. We're using this compiler for optimization purpose, and we'll learn that in our interpretation we have 2 roles, one for generating bytecode, the other one is actually carrying out these bytecodes into corresponding CPU instructions. And now it is time to talk about JIT compiler. Guess what? This JIT compiler is your optimizer. So your Turbofan is going to be your JIT compilation, JIT compiler. Okay, JIT stands for just-in-time compiler. It means in memory we have bytecode that provided by our interpreter. We have a guy called profiler that profiles our bytecode and see that okay, there is some information that is multiple time called. So for example, you have some function, it is a hot function because you are calling it multiple times, and it is one of the candidates for optimization. And this profiler provides this bytecode instructions to the compiler, our JIT compilation, and the responsibility of this JIT compiler is to take your bytecode and provide optimized code. That's how actually JIT works inside our JIT engine. Whew. I guess that's all. I hope I could explain internals of JavaScript engine. If you have any additional questions related to JavaScript engine, please don't forget to add them to the comment section. If you like my videos, please don't forget to subscribe, hit like button, share, and I'll see you in the next tutorials.